So in the previous two videos, I covered how the p and the q factors on the basic function y equals x squared. So for this video, I'm going to cover how the a values here affect the function y equals x squared. So if I have time, I will cover the last one, but I'm not sure. So this is what you learn from your high school. So when the constant a is positive, the parabola opens up. So this is what opens up shape looks like. And when the constant a is negative, the parabola opens down. So this is what the opens down parabola shape looks like. So basically the open up parabola shape looks like you are smiling. Opens down parabola shape looks like you are really unhappy, you are really upset. So notice that the vertex is at minimum point when the a value is positive. So when a is positive, the parabola opens up and the vertex is at minimum point. So this one, the vertex is at minimum point when a value is positive and when parabola opens up. So also notice that the vertex is at maximum point when a is negative. So when a is negative, the parabola opens down and the vertex is at maximum point. So this is the maximum point vertex. So next I want to compare the graph y equals x squared and y equals negative x squared. So basically y equals negative x squared, the a value is -1. So I expect to see the graph look something like this, unhappy shape. So for today's video, I will use the table values to graph the y equals negative x squared. So in the middle column, I show you the y value of the y equals x squared. So when I give the negative x squared, I just need to put the negative beside each of these values. Basically, I've completed the negative x squared by taking these numbers, I put the negative before these numbers. And I get these numbers here, and I'm using this information x and y to graph the y equals negative x squared. So the first point we have 0, 0, and the second point we have 1, -1, and -1, -1. And for the second point we have 2 to -4 and -2 to -4. So 2, -4, and -2, -4. So I'm basically using this information to generate this graph here. So this is my negative x squared graph after I plot this point and connect this point together and get this shape. So this shape has certain properties. The vertex is at maximum point 0, 0. And actually this one, the y equals negative x squared, is a reflection of y equals x squared using the reflection line x-axis, right? So imagine x-axis is your reflection line, and I reflect this one using the x-axis, and I give this image here. So we have already figured out the y equals negative x squared. The vertex is at 0, 0 is the same as y equals x squared. But be careful, y equals x squared, the vertex is at minimum point. But for y equals negative x squared, the vertex is at maximum point. So the domain is all x values. The range is y less than or equals 0. As of symmetry is the same as y equals x squared because the x value is 0 in the vertex. So also pay attention to this example. If I reflect the y equals x squared in x-axis, I get the y equals negative x squared. So next I want to know what the constant look like when the constant is greater than 1 and what the function looks like. And basically I'm setting the a here equals to 2, equals to 3, and equals to 4. So I want to see the patterns of changes if I plug in these values, 2, 3, 4. And also what happens if a value is between 0 and 1, 1 over 2, 1 over 3, and 1 over 4, the a values. And also you will know that if I reflect these function in x-axis, you will get these function as well. So I've used the graphing calculator to show you how different a value could affect the y equals x squared function. So for the black curve here, I show you the y equals x squared function. For the red curve here, I show you y equals ax squared function, and a value depends on this value. So I will move this value back and forth to see what happens for the red curve changes. So basically, for a greater than 1, I expect to see something else, right? So I can see the graph start moving and the graph start changing. So basically, if a value increases, I expect to see that the x component become constricted, right? Could you see that? Right, I hope you could see that. So when a values decreases from 10 to certain points, we could see that the shape is coming back and the x component is expanded, right? So when a equals 1, the shape is identical with y equals x squared. So what happens if a is 0 point something? So when a is 0 0.9, 0 0.8, you will see that the x component of the red curve is getting bigger, and it's getting bigger when a value becomes smaller and approach 0, right? So this is the biggest. When a is 0 0.1, you will see that the x component is become really wide here. So basically, when a value is greater than 1, we expect to see that the x component of the quadratic function is constricted. So at this time, we can see that the 4x squared is more constricted than 3x squared, than 2x squared, than x squared. So when a value is between 0 and 1, we expect to see that the x component of a quadratic function is expanded. So basically, the smallest value, the smallest fraction, the x component becomes really big than this one.